Welcome to physics class. In today's video, I want us to look at a brand new topic, current electricity. By the end of this lesson, you will learn how to define electric currents. You will also learn how to define an electrical circuit and also list and explain the various components that makes up an electrical circuit. You also distinguish between two types of electrical circuits, the closed and the open circuits. You also learn how to state Ohm's law and also verify Ohm's law with these various electrical components you are seeing on the table here. You will also investigate the effects of resistors on voltage and currents. That is when resistors are connected in series and in parallel. What is that happens to the current and to the voltage? And then finally, we are going to do a whole lot of calculations. Without wasting more time, let us go straight to the business of the day. Electricity is defined as the flow of currents or charged particles through a conducting material. We also define electric current from the equation Q is equals to IT as the ratio of charge to the time taken. Define electric current I as the ratio of the charge in coulomb to the time taken for these charged particles to flow from one end to the other end. And then during the introduction of this class, I said something about a circuit. So we define a circuit. What is a circuit? An electrical circuit is simply defined as a path that is provided for the flow of electric current. Without an electrical circuit, we cannot connect the components together. When we connect those various components together, the ammeter, the resistor, the wires, the voltmeter, they will now make up a circuit. There are two main types of electrical circuits. We have the closed and the open circuits. But before we look at the two main types of the circuits, let us look at the various common components that makes up a simple electrical circuit. Number one on the list, we have the connecting wires. The connecting wires, one of them is what you are seeing in my hand here right now. Number two, we have the power source. The power source can be the battery, one of these is called a cell, and the two we call it battery. So a battery is a combination of two or more cells. So we have the power source, also known as the battery. We also call it the EMF or the PD or the PDF. Potential difference, PDF, potential difference. And the next component that we are going to look at is the ammeter. The ammeter is a very, very important component. The ammeter, what is the function of the ammeter? The ammeter is connected in the electrical circuit so as to read the current that flows through the circuit. The next component we are going to look at is the voltmeter. a voltmeter. What is the function of the voltmeter? The voltmeter does the work of measuring the EMF, the potential difference in the circuit. The next component we are going to look at is the electrical resistor. The electrical resistors, they are of various types, and in my lab here, this is the type that we have here. We have two types of electrical resistors. We have the variable resistor and then the fixed or the standard resistor. For the one I'm holding in my hand here is the standard or the fixed resistor. For the variable resistor, we have examples like the potentiometer or the rheostat. Those ones are the examples of the variable resistors. As the name implies, there is the value of the resistance are not fixed, but they can be varied based on the value that you intend to use in your experiments. The resistor is very, very important in an electrical circuit. Just like you have brakes in your cars, without your brakes, your car are at their risk. When you enter a car that has no brake, you are putting your life in danger. So an electrical circuit without a resistor is a dangerous circuit because the electrical resistor does the work of reducing the flow of the current in the circuit. It opposes the flow of the current. It does not stop the flow of the current. It only reduces the flow of the current. It is measured in the SI units of ohm. And so we define the electrical resistor as an electrical component that opposes the flow of electric current in a circuit. The next thing we want to look at is the key. The key or the switch. Very, very important electrical components. The key does the work of controlling what happens in the circuit to on or to off the current, to make or to break the circuit. And this one is an additional component just called the battery racket, where we slot in the batteries for the connections. So these are the various common components that comes together to make up an electrical circuit. So next up, we are going to look at electrical symbols. These symbols are very, very important. They are going to help us when we want to draw electric circuits and also label them. One of them is the cell. I told us earlier that one of these is called a cell. And when we combine two or three, we call it battery. So how do we represent a cell? A cell is represented with this. You can see that the longer line here is carrying a plus sign, and then the short line here is carrying a negative sign. So this side, as you are seeing a plus sign, is this. While the other side where you see the negative sign is this. Good. So when we call it a battery, how do we represent it? When we connect two or more of this, this is how we write it. This is plus and this is negative. So you are having two of these right now. So for this, we call this a battery. The next thing we want to look at is a key. That is the symbol for the key. The next one is the ammeter. How do we present the ammeter? Like this. Where these lines, this line stands for the wires, connecting wires. Also here, this line, this and this stands for the connecting wires. Next up, we have the voltmeter. The voltmeter with a V and that. Good. Next one is the resistor. how do we represent the resistor? The electrical resistor or resistance have two representations. One, a rectangular shape with two lines on both sides. Whenever you see something like this is just for the standard resistor. So this is for the standard resistor. This is for the standard resistor. So when you see something like this, it's also for the standard resistor. So we can choose this symbol or this symbol to represent the standard resistor. So for the variable resistor, we just have something like this, and then an arrow crossing it here, or you will have something like this, and then an arrow crossing it up there. Now that we have known how to define our currents, how to define the circuits, how to define some of the components here, and how to list and explain the various components that makes up the electrical circuit, it is time for us to state Ohm's law. Ohm's law is a very, very important law in current electricity. The law explains the relationship that exists between the current, the voltage, and the resistance in the circuit. Ohm's law states that provided the temperature and other physical conditions are kept constant, the current flowing through a conducting material is directly proportional to the potential difference between its ends. Or, Ohm's law states as follows. The current flowing through a conducting material, e.g. a wire, is directly proportional to the potential difference between its terminals, provided the temperature and other physical conditions are kept constant. Mathematically, Ohm's law states that V is proportional to I. And removing the sign of proportionality, we'll have V is equals to I R. So we can call this equation number 2. Why we call this equation number 1 and this equation, number 2. We can name this equation number 3. So we have discovered 3 equations here. Q is equals to IT, and I is equals to Q over T, and V is equals to IR. I want to explain the meaning of this equation number 3. The equation is very, very, very important. In this equation, we can choose to make V a constant and vary our R in the circuit. And then as we vary R, the value of the current will also be varying. From this equation, we can still produce another equation as follows. That the current in the circuit is defined as the voltage all over the resistance. We can call this equation number 4. What is the meaning of this equation? Equation number 3 talks about what we call direct proportion in mathematics. Equation number 3 explains something as follows, that when you increase the EMF or the voltage in the circuit and you keep your resistance constant, the current in the circuit will increase definitely. And when you decrease the value of the voltage, keeping your resistance constant, the current will also decrease. So here you're going to have what's called increase, increase, and decrease, decrease. That is the meaning of this particular equation. You may also love to the value of V constant in equation number 4 and then vary your R throughout the experiment. You keep the value of V constant, and as you vary your R, you're going to also have varying values of the current. For this I and R, you have what is called an inverse proportion. So when you increase the resistance in the circuit, you decrease the current that flows in the circuit. And when you decrease the resistance in the circuit, you increase the current in the circuit. And when you increase, you decrease. When you decrease, you increase. So increase, decrease, decrease, increase. Inverse proportionality, keeping your V constant. And this is what we are going to be looking at shortly in our experiment. Next up, I want us to look at what happens to the current and the voltage when you connect resistors in series and in parallel. And so right now we're going to be looking at connection of resistors in series and in parallel. That is finding your effective or total resistance or resultant resistance in series and in parallel. So we write. So we look at resistors in series first. When resistors are connected in series, when you connect this guy in series, this is what it looks like. And so we can call this is terminal A and this is your terminal B. So for terminal A, you have, let's say this is your R1, this is your R2, and this is your R3. So how do you find the combined resistance in such arrangements? So your combined or your total resistance or your resultant resistance will be given as your RT will be equals to your R1 plus your R2 plus your R3. So if you give R1, R2, R3 values like, let's say this is 2 ohm and this is 3 ohm and this is 4 ohm, what is your combined resistance? Your combined resistance is simply 2 ohm plus 3 ohm plus 4 ohm. And you're going to have the total of what? 7, 8, 9. You have 9.0 ohm resistance in the circuit. That is how to go about it. So what happens when you connect these same resistors in parallel? When you connect resistors in parallel, this is how it looks like. When you have resistors in parallel, you have something like this. And so we call this your terminal A, and this is your terminal B. So this is your R1, this is your R2, this is your R3. When you connect resistors in parallel, how do you find the resultant resistance or the combined resistance? Very simple. Your combined resistance will be given as 1 all over R total is equals to 1 all over R1 plus 1 all over R2 plus 1 all over R3. That is how to go about it. Now let's suppose that these resistors, each of them, they are 2 ohm 2 ohm, 2 ohm. And you are asked to find the combined resistance. How do you go about it? So you have 1 all over R total is equals to 1 all over 2 plus 1 all over 2 plus 1 all over 2. At this point, for you to find the combined resistance, you take the LCM, and the LCM is 2. So 2 into 2 is 1, 1 times 1 is 1, so you write 1 here, bring 1 down. 2 into 2 is 1, 1 times 1 is 1. This plus down. 2 into 2 is 1, 1 times 1 is 1. And so you're going to have 3 all over 2. But you are having 1 all over R total. 1 all over R total equals to 3 all over 2. You aren't looking for this, so you have to reciprocate this. So that you have R total becomes 2 all over 3 ohm. And this is the value of your resistance in parallel. The value of your resultant resistance in parallel. If this is in series, what you're going to have here is 2 plus 2 plus 2, and that is 6 ohm. In parallel, you have this. So when resistors are in series, their effect is more felt in the circuit when they are in series. So if you want to reduce the effects of resistors in an electrical circuit, you have to connect the resistors in parallel. If you want to increase the effect of resistance in an electrical circuit, you have to connect the resistors in series. The last thing we are going to look at before we go into our experiments is what is that happens to current I and voltage when resistors are in series. This is very, very important. It helps and guides you when you intend to do some simple calculations in physics. Take notes. When resistors are connected in series, as you can see here, the same quantity of electric current will flow through them, but you are going to have various value of voltage across the resistors. When resistors are connected in series, you have the same current but different potential difference across each of the resistors. When resistors are connected in parallel, what is that happens to the current and the voltage? When resistors are connected in parallel, you have the same voltage across each of the resistors, but then you have different current across each of the resistors. So here, our Ohm's law equation will be customized as follows. Since you have the same current but different resistance, you're going to have your V1 is equals to IR1. This is the equation for the first resistor. And then V2 is equals to IR2. V3 is equals to IR3. The current is common, but the voltage across each of them is different. So what do you have here? Very, very simple. So for the first resistor, you have V is equals to I1 R1. We also have V is equals to I2 R2. And then you have V is equals to I3 R3. This is the customized Ohm's law equation for V is equals to IR. For V is equals to IR. This is the customized Ohm's law equation. And here too, this is the customized. Let me rewrite this. I3 R3. So this is the customized Ohm's law. V is equals to IR. V is equals to IR. So this is a customized Ohm's law equation for resistors in parallel and resistors in series. Before we proceed to do our simple experiment, there are two main types of circuits. I'm not going to explain them on the board here, but I will explain them when I'm doing the experiment. We will have the closed circuit and the open circuit. So before we run our experiment, it is very, very important I combine these components and I draw a simple electrical circuit. I'm going to draw a circuit for parallel resistors and also a circuit for series resistors using these various electrical components. So this is you have this resistors, resistor 1, resistor 2, and resistor 3. They are connected in series, and your ammeter is somewhere here, and you have two cells here. Down here is your key. So we are going to use this circuit to connect in our experiments. So if you have one of these is 1.5. So if you have two of them combined, you're going to have 1.5 plus 1.5. So the source here is 3.0 volts. And so conventionally, the current will flow in this direction. The current will flow through this direction. So you have your arrow facing this side, up here, back here, and if you close the circuit, this is how the current will flow. Good. Next up, we said that when resistors are in series, you have different potential difference across each of them. So this is your R1, this is your R2, this is your R3. So you're going to have your V1, your V2, and then your V3. So if you connect a voltmeter across these resistors, this voltmeter will read remember, the voltmeter is always connected across the resistor. Good. So we have a complete electrical circuit. We have the voltmeter, which was here. We have the ammeter, which was here. We have the battery, which was here. We have the connecting wires. We have the resistors. We have the key. So this is a complete electrical circuit for a series resistors. So these are the electrical wires. So we can count how many wires we have here. We have 1, we have 2, we have 3, we have 4, 5, 6, 7, 8. We have 8 connecting wires in this particular circuit. Let us draw a circuit for parallel resistors. So we're going to have different currents for each of these resistors. And in summary, just as I was saying, the equation here, the Ohm's law customized equation here, V is equals to IR. We have it as V1 is equals to IR1. V is equals to I3R3. So these are the equations that we are going to use when we are working with our experiments. So in our next class, we are going to verify Ohm's law and also verify the effects of series resistors and parallel resistors on current and voltage. Thank you.